In this video on tools, I'm going to be discussing impact drivers and drills. While these two tools look similar and can perform many of the same tasks, they operate in a different way, which makes each one better suited for specific tasks. I'll start out by pointing out the differences between these two tools. Now, the first thing you may notice is that on this one we've got a much larger black tip on it. Then on this one we've got this much smaller tip. Not counting this adapter. This is not part of the drill. This is the drill, just like this drill bit is not part of the drill. So we've got this larger black piece here, and this is called a chuck. And what this does is this holds the drill bit or the screwdriver tip that you're going to use with this tool. Now this one happens to be a keyless chuck, which means that I can open it up and close it by hand. On most cordless drills anymore, they almost all come with a keyless chuck. You'll still find a keyed chuck on some heavier duty drills, especially if they're corded. And what that means is that you can't open it, a keyed chuck you can't open by hand. It'll have a little gear around here and a little hole, and usually on the cord of the drill there'll be the key. And that key fits into the, mates with the chuck, and then you turn that to tighten or loosen the chuck. So as we turn this chuck, there's these three little arms or fingers, if you will, that come in and out and will pinch or grab onto whatever you want to put in here. So for instance, with this drill bit, this is a really small drill bit, so the shaft of it is really small. So I can just keep turning this until it pinches all the way down, and it holds this drill bit. Now this is a chuck is really nice because you can hold a variety of different sizes. It can, some drill bits that are larger, you can just open it up wider and put that in there, and then the smaller ones you just close down on it. Now with an impact driver, there's no chuck. There's just this little piece that has one hole in it, and you'll see that this part pulls out and then springs back into place. And what that does is that holds just a single sized piece. It's a little octagon here. Little metal octagon, and it has this little divot on the side of it, which allows something to catch on it on the inside of this and keep it from falling out. So to insert this, you just slide it in and then release that, and then it's locked into place. So this is nice because you can very quickly and easily change pieces if you want to switch out your tip. But it's also not nearly as versatile as having a chuck. A chuck can hold anything of different sizes. Now they do make an adapter that fits into one of these that then adds a chuck. I've never used one. I always have both drills available to me, and I really just stick to the adapters or the drill bits that are meant to be used with this. The other big difference between these two tools, which may not be very obvious from looking at them like the chuck or the tips were, is how they operate on the inside. The drill, for argument's sake, there's a motor in here which is directly connected to the tip. In reality, there's some gears in here and you can make some adjustments, and there's this torque adjustment here that I'll talk about in a second. But for argument's sake, this motor is directly connected to this end. Now there's some advantages and some disadvantages to that. One of the advantages is that as you're driving a screw, when that screw drives all the way in, it's going to become more difficult to drive. It's not going to want to go any farther in. And so the screw is going to want to stop turning. Well, since this is directly connected, something has to turn. So you'll feel the drill itself want to turn because the screw is going to want to stop turning, and so the drill is going to want to start turning. Well, the advantage of that is that you become very aware of that as you're using a screwdriver, and that when you're screwing a lot of screws, you'll kind of automatically know when the screw has hit its maximum. You'll know how far it's gotten. The other advantage of having that direct connection is that you can easily control the speed of this end. So, this drill, it's a variable speed drill. So when I pull the trigger back all the way, it goes to full speed. And when I lessen the trigger pull, then this thing slows down. So I can get very precise with this drill. I can put the adapter or the drill bit exactly where I want to screw the hole, and start out slow, and once I start to get into the wood a little bit, I can then increase the speed and drive all the way in. So there are some advantages of that. But there's also, as I said, some disadvantages, which is where the impact driver comes in. This impact driver, there is no direct connection between this bit and the motor itself. Instead, the motor is essentially hammering in a rotational direction, so it's not hammering the bit this way, which is what a hammer driver does, a hammer drill does. It's hammering in a rotational direction. So instead of just directly turning this drill bit or the screwdriver tip, it's hammering it around. And the advantage of that is that when you're driving a screw, there's not a consistent amount of torque that's being applied to the screw. And instead it's coming in very strong short bursts. So this driver is fantastic at driving screws that you just simply couldn't drive with this. If you had a screwdriver tip on it and you're driving a screw, when the screw starts to, really get torqued out or get maxed out, like if you're driving a 3.5-inch screw into a piece of wood, about 2 inches in, that screw is going to really have a hard time turning. Well, this is going to apply a constant amount of torque to that screw tip, and something's going to have to give. If that screw isn't going to go in or is having a hard time going in, something's going to give. Either this drill is going to want to turn, or the tip of the tip of the screw is going to strip out. So when you're driving larger screws, it's very common for this to strip out a screw. This, on the other hand, so this would be difficult to drill or to screw a 3.5-inch screw. This, on the other hand, it's short bursts of heavy torque. You don't feel, as you're driving it and that screw starts to slow down, you don't feel any rotational force with this because there's not a direct connection here. Instead, that little hammer, it may slow down, the screw may slow down at the rate in which it goes into the wood, but you're not going to feel it here, and this is very unlikely because it's unlikely to strip out the screw because it's not applying that constant force on the head of the screw. So this driver excels at driving long screws that you just couldn't get away with the screwdriver. This screwdriver excels at drilling. You can get drill adapters for this, but this thing doesn't really come in that much of a variable speed. There might be 2 speeds in this, but it's not great for drilling and it's not very precise. But if you want to screw something that you don't want to have to worry about stripping out the head, this is the guy to do it. If you want to drill or be a little bit more precise, you're going to want to use a drill. One of the downsides to using the impact driver is that because of that hammering action that's happening inside the tool, it can get a little loud. I'll demonstrate on this log. Now, as I said, on a drill, we've got this direct connection between the motor and the drill bit. Now, that's true for the most part, but there is the problem with that could present if that was truly the case is, as I said, that when the screw wants to stop turning, something has to give. So either the head of the screw is going to get stripped, or this is going to want to turn. Now, if you're holding this solid, if you're holding this perhaps down here and you've got your body directly behind it, and the screw stops turning, almost guaranteed that the head of the screw is going to strip out. But occasionally what will happen is you'll have to hold the screwdriver in a weird position where you won't have it as strong. So instead of and when the screw stops turning in that case, instead of the head of the screw stripping out, the weaker point is your wrist. It's going to want to turn the screwdriver because you don't have a good hold on it. So in that case, you could hurt yourself, and I've done it before where I'm screwing in a screw and I'm underneath a trailer, for instance, and I've got it out in a weird position, and then all of a sudden it hits its maximum and the screwdriver turns and it yanks my wrist. So there's this setting on here that's called a torque adapter. And what this does is this breaks that continuous line of transfer of power from the motor to the tip. This will break it when it hits a certain amount of torque. And that torque is adjustable. So on this setting, this one's got 25 different settings on it, and you can just dial it in. The lowest setting, as soon as it hits just a little bit of torque, you're going to hear this thing start to break. It's not really breaking, but the clutch inside is breaking. So you'll hear it start to go click, 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 click. The motor will continue to turn, but the tip will stop turning. Now on the highest setting, you'll see a picture of a drill bit, and that's what you normally use when you're drilling a hole, because you don't really there's no amount of torque that you want to stop the drill bit from turning. And that, when that's set on the drill bit setting, that is a continuous line. This clutch will not break. So you need to be careful with that. If you're driving a screw, you definitely don't want to put it on that, because either the head of the screw is going to turn or the screwdriver is going to turn. Now, where this comes in handy is on things like when you're drilling or you're driving the screws for the metal roofing. You don't want to drive the metal roofing screws too far, because they'll start to bend the metal. And so you can set this to something pretty low and test it. And if you set it at the lowest level, more than likely it's not even going to make it all the way down. The screw's not going to make it all the way down to the metal roofing. But so when you start driving it, if it doesn't make it down, you just adjust it, make it a little bit higher, drive it a little bit further, and then you can set this to where you can drive these and you don't have to worry about damaging your roof. The drill will automatically stop when it hits the appropriate amount of torque, whatever you've determined that to be. Now on a hammer drill, we've got the same torque adjustment, but there's the picture of the drill bit, just like on this guy. But then the next one over is a picture of a hammer, and that's because this is a hammer drill. And what happens when you put the drill on that setting is not only do you have this rotational force, but with the hammer setting, you've got essentially a hammer hitting the back of this thing that's pushing the drill bit in at the same time. And so when the impact driver, the hammering is in the rotational direction, but in the hammer drill, the hammering is in the linear direction. It's driving in line with the drill bit. Now the only place that I've ever had to use this is when you're drilling concrete. Concrete, since it's made up of sand, as you start to drill, the drill bit can't really grab on anything like it can with wood to pull the drill bit through the material. With concrete, instead, it just kind of ends up sanding it down and making it real nice and smooth. And then when the drill bit's not penetrating into the material, then a lot of heat is generated, and you'll just end up burning up your bit. So the hammer drill, as it's turning, there's that hammering action that's happening at the same time, and so that's kind of chipping away at the concrete and letting you dig in a little bit. So I don't really use this too much on tiny houses. Now where I do use it is when I'm drilling through the studs to run the wires. And I don't use the hammer setting. The only reason I use this bit is the opening on the chuck is big enough to fit the drill bit that I'm using to drive through the studs. On larger drill bits, they'll often make the shaft really big, and they won't fit into something. Even when this one is opened up to its max, I just can't fit that drill bit into here. And they do that because the drill bit is big, and the piece of metal they're using, they can just extend it down to fit into here. And they also do it because it's a really big bit, and if you try to use it on something like this, I may very well burn up my drill. This one I don't have to worry about. Burning it up. It's a little bit heavier duty for such a big bit. Another setting on this drill is a speed selector. Now on this particular brand, this is Ryobi. This is on the top, and it's a 1 and a 2 are my options. On this DeWalt, it's also on the top, and it's a 1, 2, and a 3. Now what this does is this adjusts the maximum speed of the drill. Now the higher numbers means it'll go faster, but with that speed you lose some torque. So if you're doing something that requires a lot of torque, like driving a long screw or drilling a large hole, then you're going to want to set this on a lower setting so you have that torque. It'll go a little slower, but it'll be stronger. Now if you're doing something where you're driving small screws that don't require a lot of torque, and you want that to happen really quickly, or you're drilling a small hole, then you're going to want to set this on a higher setting so that you can do the job faster. When you look at these drills and drivers in the store, you're going to see that they come in all different voltages. This one is, these three I believe are all 18 volts, and then this smaller one is a 12 volt. Now the lower the voltage, the less expensive they are, but they also run out of battery quicker, and they're not as strong. So I have this one, I have the small 12 volt one for small household jobs. It's really small and light, and so I like it for that. But when I'm building a house, I very rarely use this. I've used it in the past because I've run out of battery, but I'm surprised at how quickly it runs out of battery. So for those, I would recommend that you get at least an 18 volt system. In addition to different battery sizes, there's also different battery technology. This older stuff has what's called NiCad, and these you can still find this in the store, but it's not as common. And NiCad is less expensive, but it's also a lot heavier, and the tool gets weaker as the battery drains, and it'll just continuously get weaker until it's completely dead. Now with the lithium ion, just picking this up, this tool is considerably lighter than this tool. And then another nice thing about this is that this one has a little battery gauge, which I can push the button and it'll tell me how strong the battery is. And the tool doesn't really lose power until the battery's dead. So the tool will have a consistent amount of power, and then all of a sudden it'll drop off and just stop working. With these NiCads, they just keep getting weaker and weaker, and then eventually you just have to charge the battery. Now, if you want to get really fancy, one of the newest features is called brushless motors. And brushless motors use about half the energy that these use, so your tool lasts a lot longer, but you also pay for it. When you buy these tools, I definitely recommend that you buy them in a box set. The box set usually comes with a couple batteries and a charger, and since the individually packaged tools are so expensive, there's quite a bit of savings when you buy it in a set.